Hayduke is now patrolling the backyard. He seems to think that maybe some squirrels will be out in the sunshine that he can go chase. I, meanwhile, am still doing physics problems. So, here's the next one we're going to talk about. Number 6. Two objects with the same mass travel toward each other at 10 meters per second each. They collide and are reported to rebound, each with speed 20 meters per second. Which assessment of this report is most accurate? So we're given here 4 different statements, and we're supposed to figure out which of the statements makes sense. Let's start with A. The first option, A, says momentum was not conserved, therefore the report is false. Well, does that statement make sense? Let's look at... Hello. Did you need something? Okay, just checking. So let's figure this out. Before the collision, what was the sum of the momentum of the two things? We'll take momentum of thing 1 and momentum of thing 2. So that means mass 1 v1 plus mass 2 v2. We know the mass is the same. And we know that their velocities were the same, but in opposite directions, right? So the magnitude was the same, but since they're vectors, we have to treat them like vectors. One of them has to be negative. So we end up here with the sum of momenta before the collision, 10m minus 10m, which is 0. So the momentum of the system before the collision is 0. All right. Now, in order to see if momentum was conserved, we have to figure out what the total momentum was after the collision. So let's do that. Sum of the momentum after is, again, number 1 plus number 2. So if we add that up, I'll dispense with talking about this math because you all know it. We end up with the sum of the momenta after the collision is 0. So, in other words, this proves that momentum was conserved. What that means is A can't be right because A said momentum was not conserved, therefore the report is false. But look, momentum was conserved. So A can't be correct. There. A doesn't work. Now let's talk about B. Is it possible that B works? We'll figure it out. If the collision... Hold up. There. If potential energy was released to objects during the collision, the report could be true. This is kind of sticky because I can't think of a situation in which that would happen, but I suppose it could. So let's talk through it and see if this makes any sense at all. If the collision was inelastic, kinetic energy would not be conserved, right? The balls would bounce back with less energy or less speed. If the collision was perfectly elastic, kinetic energy would be conserved. So we'd expect the balls to bounce back with the same energy they had before. What would that look like? It would look like they'd have the same speed as they did before. So in other words, if they were coming toward each other at 10 meters per second each, and the collision was perfectly elastic, kinetic energy would be the same after the collision, so they'd be going back away from each other at 10 meters per second each. So now following that line of reasoning, we could say if the collision involved adding energy at the moment of impact, say somehow when they hit each other, they tripped some fireworks that blew them apart more. I don't know. But if we added energy at that point, kinetic energy in the system would increase, right? So that means the balls might bounce back with greater energy. What would that look like? It would look like more speed. They'd both have the same amount of speed, right? They'd have the same amount of energy, they'd have to share it. So this would work. It's weird to think about. It's not particularly intuitive, but we can't think of a reason why that statement can't be true. Let's not scribble it out just yet. Let's keep going and look at the other alternatives. Here's C. The option C says, if the objects had different masses, the report could be true. So how would we go about proving or disproving that statement? I think we could just do the math, figure it out, right? So let's make one of the things twice as massive as the other, just to make this math look easy. Before the collision, the sum of momentum, or of momenta before the collision, 2m times 10 plus m minus 20. So we've made the ball moving in the positive directions twice as massive as the other ball. Again, that's just sort of arbitrary. We just did it because it was easy to do the math that way. That means that the sum of the momenta before the collision would be 20m minus 10m. We'd end up with 10m being the sum of the momenta just before the collision. So what about after the collision? We'll do it again. If the statement was true, after the collision, we'd end up with a sum of momenta of 20m. Well, 20m isn't the same as 10m, right? It won't work. In this case, momentum is not conserved, and we know that it has to be conserved. So we don't like this. This won't work. Go away. We don't like you. Okay, let's talk about D now. If the surface was inclined, the report could be true. If the surface was inclined, the report could be true. So this is what we're talking about, right? We're talking about two balls of equal mass going toward each other at equal speed on an incline. We're assuming that this incline is on some planet with gravity. Here's what I wrote. There's nothing about that makes any kind of sense, right? I don't even know where to start in disproving it. I'm sure that you could, but let's not. It just doesn't make any intuitive sense at all. So let's just go ahead and say, no, 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 we don't like you, no. Let's go back now to B, which is the only one we haven't scribbled out. Let's look at it again. Let's be sure it kind of makes sense. If the collision was inelastic, kinetic energy wouldn't be conserved. If it was perfectly elastic, it would be conserved. So if by the same token we added energy, the balls might bounce back with greater energy, which would look like more speed. So at this point, I want to show you, I wrote it down. Where is it? Oh, here it is. I want to show you this. We've talked about this earlier in the year. I think it's a really, really good thing to keep in mind. Once you eliminate the impossible, whatever remains, no matter how improbable, must be the truth. We don't like that B is the correct answer. You're not comfortable with it. I don't like it a lot either because I have a really hard time visualizing how it might happen. But it's the only thing that makes any sense at all. So we're going to go with B as an answer, and that's what the key says as well.